Hi, I'm Stefan. Welcome to the TwoStack Developer channel. Today, we're going to be stepping away from working on our local node in the regression test mode a little bit, and we're going to venture out onto the public test network for the first time. Now, in order to do that, a few things will have to change. For one, we will need access to testnet bitcoins, right? So we will still generally have the same shape to our workflow, which is that Alice has an address where she will be receiving funds on, and we need to fund Alice's address before we can actually spend money from there. And that funding transaction for Alice, we need to get something like that on the public testnet. Now, we don't have the ability to generate our own coins out of thin air using a regression test mode node anymore. So what we'll have to do instead is we'll have to use something called a faucet, which is a free source of testnet bitcoins that we can get access to. The faucet we'll be using today is this one right here, located at testnet.satoshis.vision.network. Say that 3 times quickly in a row. Okay, and so let me grab Alice's address and show you how this is done quickly. I mean, it's a website, right, where you basically dump in an address. It's not address is okay. I can't send until I've proven that I'm not a robot. Okay, it doesn't want to send me to the same address again immediately. This faucet is a little bit miserly. So I've already sent some bitcoins to this address before. However, if you recall, that is just one part of it, right? We need to send funds to the address. So what we did before was we mined some Bitcoin on our local node. We send from the local node's wallet to Alice's address, and then we grabbed the transaction ID for that, and then we basically grabbed the raw transaction associated with that and used that as the funding transaction, because that is the transaction that contained the UTXOs. Now, fortunately for us, because we're going to be working with the public test network, there are some really cool third-party tools that we can use. We funded Alice's wallet or Alice's address with a transaction, but we don't really have an idea or a clue where that money is. So I think we need to go and find it. And the way we find it is there is this API which essentially allows us to query via a GET request what the UTXOs associated with an address are. This is very useful. And all we need to do is essentially execute this curl command that they give us here, a very helpful curl command. So you can basically just curl on the endpoint. I'm going to go back to my IDE. Right, so what do I want to do here? Okay, the things that I want to do in here is essentially that I want to issue this GET request. You don't need that, you don't need that. I do need to change main to test because we're going to be sending onto the test network. And then I'm going to query and ask about Alice's address. Yeah. Oh man, I don't want you to follow. No, don't follow the. It's trying to follow. It's trying to follow the. Right. So this should give us back information about the transactions. So we've got a few here. We've got one transaction hash. The transaction hash, basically what they call a transaction hash, we call a transaction ID. It's the same thing, right? The transaction ID is actually a hash of the transaction. People call it a transaction hash or a transaction ID. So we've got 1, 2, 3, 4, 5. And maybe if I jump out of the container quickly, I could probably pipe this into JQ so that we can get a little bit prettier view of what is actually contained in there. So here we see that we actually get this structured data back, right? The block height, the position in the transaction that the output is that our UTXO is in, the hash, and the amount. We've got 10,000 Satoshis here. I think I found it. There's a different one, which is just get raw transaction, which is this right here. Okay, let me see if this works, right? Raw transaction, want to take this hash, which is, okay, let me show you what I'm doing over here. So this is what I want to paste, right? Which is, let me make sure that I get the right thing this time. And I want to, okay, let me quickly close this. I want to say curl -x get, and I want to change the network to test tx for this one. I'm missing a quote. Come on, Stefan. That's it. That's the one that I want. This is a proper raw transaction. Now we just proceed as per normal. I'm going to go back into my application. I need to paste Alice's funding transaction in here. Let me strip that percentage sign at the back. Otherwise, unexpected things will happen. Our output index is 0 in that transaction. Okay, so that is confirmed. We now have Alice's raw transaction. I'm going to send from Alice to Bob's address. How many am I sending here? That's 1,000, that's 10,000. I'm going to send the 10,000 Satoshis to Bob. I'm going to generate the transaction now, and then we need to broadcast that transaction into the node, right? So this is the raw transaction that we're getting back, and we need to now take this raw transaction and send this raw transaction onto the larger network. So let me paste. Okay, now I've got a different problem. I need to go back here, copy this, paste this here, and simplify the call a little bit so that it's a little bit more obvious. We're going to send on the testnet. This is the endpoint. We're going to, this is our header for curl. This could be shortened to just -h. Content type is application JSON. This is correct. We're sending TX hex. Let me do this. And I don't need that. Then it will become cleaner and more obvious what we're actually doing. And inside here, we'll be sending our raw transaction hash right in there. So I need to go back to the screen where I got the raw transaction, paste that in there. And I know that this looks like a lot of ceremony, but you know, developers. Okay, so the network has accepted our transaction. It's given us back a transaction ID. We can now take this transaction ID over to the web browser, go to the Block Explorer, and essentially ask the Block Explorer to tell us about this transaction ID, right? And there we see it's an unconfirmed transaction where we're sending from this address, which is N3VK to MPJF. And yeah, sorry for the technical glitches, but that is essentially the roundabout way in which we need to work manually with interacting with the testnet. Now, obviously, the manual way is depending on how you're lining up your tooling and your setup and your workflow, could be a very quick way for you to test with the testnet. Typically, what one will do though is program these programmatically broadcast, right? Because it's a RESTful endpoint. We don't need to use command line tooling. We can write the HTTP client code that would actually allow us in our application to do it. There is a reason why I'm actually doing things manually in this way, specifically because it's important for us to start forming a really good intuition about the shape of the Bitcoin network. And we're back. As I was saying, it is important for us to continue building an intuition for the general architecture of this problem space that we are in, right? The set of problems that we are solving at the moment, which is that of moving money between Bob and Alice, this translates the same whether or not we're on the Regression Test Mode Node, the Public Test Network, or the public main network for Bitcoin. The shape of this problem is the same. There are always two or more parties involved. You're always going to try and build or create a transaction of some sort in order to allow these two parties to interact, or two or more parties to interact with one another. The tooling around the edges might change from time to time, and they might become a little more sophisticated in order to make our lives a little bit simpler around the edges, but we're doing things from first principles at the moment so that we can get a good understanding of what it is that we're actually working with, right? And how to translate these fundamental concepts and build on them to do the same thing at a larger scale for our users, right? I hope you enjoyed today's episode in spite of all the technical difficulties, and I will see you next time.